Imagine for a moment that you're looking at the night sky and seeing only a tiny fraction of what really exists up there. Now answer me, how would you feel to discover that more than 1.5 billion cosmic objects are hidden right in front of you, invisible to your eyes? Entire galaxies, newborn stars shining in distant stellar nurseries, and some of the oldest stars in our entire galaxy. All of this camouflaged by a cosmic haze that has blinded us for millennia. Seems frustrating, doesn't it? Well, prepare to have your mind completely transformed, because this reality has just changed forever. Thanks to the VISTA Telescope from the European Southern Observatory, we have finally managed to tear through this cosmic veil and reveal wonders we never imagined existed. For the first time in human history, we have a comprehensive infrared map of the Milky Way, a map that cuts through the dark dust of space like a blade slicing through darkness, revealing an unprecedented view of our galaxy and what lies beyond it. And the discoveries I'm going to share with you today will completely change the way you see the universe around us. Did you know that traditional telescopes can only capture visible light in a range between 380 and 700 nanometers? It's as if we were observing the cosmos through a window with half-closed curtains. But VISTA is different. It operates at infrared wavelengths between 900 and 1200 nanometers, allowing it to detect completely invisible objects, stars obscured by cosmic dust, and cold brown dwarfs, also known as failed stars, which simply don't emit enough visible light to be seen. To give you an idea of the brutal difference between these two perspectives, imagine the Lobster Nebula. In visible light, we see a beautiful, colorful formation, but when VISTA points its infrared eyes at it, the dust that obscures our vision simply disappears, revealing hundreds of thousands, perhaps millions of previously invisible stars. It's as if someone had turned on the lights in a dark room full of hidden treasures. This revolutionary mapping was created through the VVV project, VISTA Variables in the Via Lactea, and its extension VVVX. The data collected by these projects has already resulted in the publication of more than 300 scientific articles, each revealing secrets that had been kept for billions of years in the heart of our galaxy. Unlike other recent space maps, this is one of the most detailed ever created. It's the first infrared survey to cover almost 80% of the luminous mass of the Milky Way, providing the largest infrared catalog ever made of the central region of our galaxy. It allows us to study our galaxy with microscopic precision never before achieved. Think about this. This survey covers an area of sky equivalent to 8,600 full moons and contains about 10 times more objects than any infrared map published previously. Our Milky Way consists of a central bulge, a dense and bright collection of stars with a flat disk of 2 spiral arms around it. And it was exactly in this central region, previously hidden by cosmic dust, that the most impressive discoveries were made. Dante Miniti, the Argentine astrophysicist who led this project, said something that gives me chills every time I think about it. We made so many discoveries that we changed the view of our galaxy forever. And when you discover what they found, you'll understand why this statement is no exaggeration.
In 2015, VISTA turned its attention to the star-forming region known as Messier 20, also called the Trifid Nebula, located about 9,000 light-years from Earth. In visible light, we see a stunning nebula glowing pink due to ionized hydrogen emission. But when VISTA penetrated through the clouds with its infrared eyes, it revealed a completely new swarm of stars. And here comes the part that will surprise you. By chance, this observation revealed objects on the opposite side of our galaxy that had never been seen before. Astronomers identified 2 red and faint objects as Cepheid variable stars, Although they appear in the image right behind the Trifid Nebula, they are actually about 7 times more distant than the nebula that previously blocked them from our view. Cepheids are bright but unstable stars that increase and decrease in brightness over periods ranging from a few days to a few months. They function as a kind of cosmic ruler that can be used to measure distances up to tens of millions of light years. If you know the star's pulsation period, you can infer its absolute brightness and age, comparing this with the apparent brightness that reaches us on Earth. But the discovery that really changed everything happened when a team of astronomers found 655 candidate Cepheid stars in the direction of the galactic center. Of these, 35 were classified as classical Cepheids, the youngest of the group. This was revolutionary because the galactic bulge had always been considered an exclusive home to old stars at least 8 billion years old. Recording their pulsation periods, the team revealed that all these 35 Cepheids were less than 100 million years old, and some may be only 25 million years old. To put this in perspective, our Sun is about 4.5 billion years old, so the youngest Cepheid has existed for only 0.6% of our Sun's lifetime. The exploration of these Cepheids culminated in an even more impressive discovery. By mapping these 35 classical Cepheids, the team managed to track a completely new feature in the Milky Way, a thin disk of young stars that extends throughout the galactic bulge. Buried behind thick clouds, this structure remained unknown in all previous surveys of the region. This discovery revealed that there has been continuous stellar formation along the median plane of the galaxy for the last 100 million years. We used to think that the galactic bulge was an ancient feature of our galaxy's past, where exclusively old stars had formed separately from the stellar disk. But this discovery shows that things are not so black and white. Even more inspiring is a discovery that reached the ancient heart of our Milky Way. In 2016, for the first time, a type of ancient star known as RR Lyrae was discovered in the center of the galaxy by a team led by astrophysicists Dante Miniti and Rodrigo Contreras Ramos. This type of star is usually found in globular clusters that tend to orbit the outer regions of the galaxy. A globular cluster is a densely packed group of stars containing tens of thousands to millions of stars bound by gravity. They are really ancient, containing stellar populations that may be more than 10 billion years old. The team found 12 RR Lyrae stars during the VVV survey, suggesting they may be the remnants of an ancient globular cluster right in the heart of our galaxy. This discovery also provides evidence that may help astronomers decide between two competing theories about how nuclear bulges form. While some scientists think that the nuclear bulge forms early in galactic evolution when multiple smaller galaxies collide violently, others say it forms gradually over time, where gas is channeled inward to trigger stellar formation. Finding these ancient stars here suggests that the expanding center of the Milky Way probably grew through the merger of primordial globular clusters. Speaking of ancient stars, VISTA managed to find 2 new globular clusters as part of the infrared survey in 2011. There were only 158 known globular clusters in the Milky Way before these new discoveries. For the survey to identify 2 more of these rare stellar objects is quite a significant achievement. Within the central region of the galaxy, it's easy for younger stars and cosmic dust to obscure globular clusters, especially because their age prevents them from shining as intensely. But now they have been revealed, bringing exciting possibilities for future studies. Scientists wonder if one of these new clusters is gravitationally bound to another known one. If this is the case, They would be the first known binary pair of globular clusters in the Milky Way. We've already found binary clusters in other galaxies, and scientists think it may be when these gravitationally bound clusters collide that we get the most massive globular clusters. Besides globular clusters, the VISTA infrared survey identified a multitude of other types of stellar clusters. At least 96 new open or galactic clusters were found, which typically contained fewer and younger stars, being much more common than the globular type. The absolute scale of this survey is impressive. Covering a vast region of the sky and mapping more than 1.5 billion objects, this data has already led to fascinating discoveries that are rewriting our understanding of the Milky Way and beyond. And this is just the tip of the iceberg. This survey will serve as a foundation for future telescopes and observations, which we hope will be able to expand VISTA's legacy with even greater resolution and sensitivity. We now have the most detailed 3D map ever made of the structure and objects of the Milky Way, one that revealed hidden wonders previously beyond our reach. With information from this revolutionary infrared survey, as well as recent work from ESA's Gaia mission Invisible Light, this is an exciting time to be an astronomer. We can expect a flood of new insights about our own galaxy and the universe as a whole. VISTA's infrared observations revealed dozens of hidden stellar clusters and millions of previously invisible stars. They revealed new stellar nurseries where stars are born and expanded our understanding of the Milky Way's formation. Looking at the sky through different wavelengths has brought a new era of galactic exploration. If this content opened your eyes to the hidden mysteries of our universe, don't forget to like this video and subscribe to the channel so you don't miss any of the upcoming discoveries we're going to share. And since you've made it this far, how about watching one of our videos that are appearing now on your screen? I'm sure you'll be even more surprised by the secrets that the cosmos still holds for us. Until the next adventure through the universe.